Meet Maya. She's 12 years old, and she just got a part-time job walking dogs in her neighborhood. She charges the same amount for every dog she walks. But now her mom wants to see a table and a graph to make sure Maya's prices are fair. Maya stares at her notebook and thinks, where do I even start? That's exactly what we're going to figure out today. Let's unlock proportional relationships together. So what exactly is a proportional relationship? It's when two quantities, like dogs walked and money earned, grow together in a perfectly consistent way. Every time you walk one more dog, you earn the exact same extra amount. The ratio between the two values never changes. That steady, unchanging ratio has a special name: the constant of proportionality, written as K. It's the heartbeat of the whole relationship. Tables are one of the best places to spot a proportional relationship. Here's the trick Maya learned. Divide y by x for every single row in the table. If every single division gives you the same answer, congratulations, it's proportional. That answer is your constant of proportionality, K. If even one row gives a different answer, the relationship is not proportional. Let's see this in action with Maya's dog walking business. Now let's talk graphs. A proportional relationship has two special features on a graph. First, it makes a perfectly straight line. Second, and this is the big one, that line must pass through the origin, the point 0, 0. If your line is straight but starts somewhere else, it is not proportional. The slope of that line is your constant of proportionality, K. And the equation? A beautifully simple y equals K times x. Here's Maya's favorite part: finding K, the constant of proportionality, which is really just the unit rate. It answers the question, how much y do you get for every one x? Maya charges $5 per dog, so K equals 5. That one number, 5, unlocks the entire pattern. Walk 2 dogs, $10. Walk 7 dogs, $35. Once you know K, you can predict anything. That's the magic of proportional relationships. Let's check Maya's dog walking table together. She walks 1 dog and earns $5, 2 dogs and earns $10, 3 dogs and earns $15, and 4 dogs and earns $20. Now let's divide y by x for each row. Row 1, 5 divided by 1 equals 5. Row 2, 10 divided by 2 equals 5. Row 3, 15 divided by 3 equals 5. Row 4, 20 divided by 4 equals 5. Every single ratio equals 5. So yes, this is a proportional relationship, and K equals 5. Now Maya's friend Jordan has a table too. His x values are 2, 4, 6, and 8, and his y values are 6, 12, 19, and 24. Let's check the ratios. Row 1, 6 divided by 2 equals 3. Row 2, 12 divided by 4 equals 3. Row 3, 19 divided by 6. That gives us about 3.17, which is not 3. Row 4, 24 divided by 8 equals 3. Row 3 breaks the pattern. Since the ratios are not all equal, this table is not proportional. Jordan must have made a mistake. That y value should be 18, not 19. Maya plots her dog walking earnings on a graph. The x-axis shows dogs walked, and the y-axis shows dollars earned. She plots the points: 1, 5, 2, 10, 3, 15, and 4, 20. She connects them and gets a perfectly straight line that passes right through the origin, the point 0, 0. This confirms it's proportional. Now, to find K from the graph, we pick any point. Let's use 3, 15. We divide y by x. 15 divided by 3 equals 5. So, K equals 5, exactly what we found in the table. Maya wants to write an equation so she can quickly calculate earnings for any number of dogs. We already know K equals 5, so we plug it into the formula y equals K times x. That gives us y equals 5 times x, or simply y equals 5x. Let's verify. If x equals 6 dogs, then y equals 5 times 6, which equals $30. If x equals 10 dogs, then y equals 5 times 10, which equals $50. The equation does all the work. Maya is seriously impressed with herself right now. Let's try a trickier one. A table shows x equals 3 and y equals 7.5, x equals 5 and y equals 12.5, x equals 8 and y equals 20. Are these proportional? Let's check. Row 1, 7.5 divided by 3 equals 2.5. Row 2, 12.5 divided by 5 equals 2.5. Row 3, 20 divided by 8 equals 2.5. All three ratios equal 2.5. It's proportional. So k equals 2.5, and our equation is y to equals 2.5x. Notice that k doesn't have to be a whole number. It can be a decimal too. Last example. Look at this graph. It shows a straight line, but the line crosses the y-axis at the point 0, 3, not at the origin 0, 0. Even though the line is perfectly straight, it does not pass through the origin. So this relationship is not proportional. It's actually a linear relationship. Straight line, but not proportional. Remember, for proportional, the line must go through 0, 0. That's the golden rule of proportional graphs. Maya's got it memorized now, and so do you. Here's the big picture takeaway. There are 3 ways to recognize a proportional relationship, and they all connect perfectly. In a table, every y divided by x gives the same value, k. On a graph, you see a straight line that passes through the origin. In equation form, it looks like y equals kx. The beautiful thing? All 3 representations describe the exact same relationship. Switch between them freely, like a math superhero. Maya now moves between all 3 without breaking a sweat. Remember when Maya was staring at her notebook, totally confused about how to show her dog walking prices? Now she can build a table, plot a graph, check every ratio, and write the equation y equals 5x, all in minutes. From lost to legend, that's Maya's journey, and it can be yours too. The keys are simple. Find k by dividing y by x. Make sure your graph passes through the origin, and write y equals kx.